Hello students, welcome to my channel. In this class, I am going to teach you graphical solution of LPP. So let us start the topic. Find the maximum value of z is equal to 5x1 plus 3x2 subject to the constraints 3x1 plus 5x2 lesser equal to 15, 5x1 plus 2x2 lesser equal to 10, x1, x2 greater than equal to 0. So here 3x1, 5x2 is equal to is less or equal to 15. Let 3x1, 5x2 is equal to 15. For x1, for x2 is equal to 0, we get 3x1 is equal to 15. So x1 is equal to 5. For x1 is equal to 0, we get 5x2 is equal to 15. So x1 is equal to 3. Here x2 is equal to 0 and x1 is equal to 5. The point will be on the x-axis and the point will be on x-axis, that is 5, 0. And here this x1 is equal to 3, x1 is equal to 0, x2 is equal to 3. The point will be on y-axis. So let us take y-axis and this is the x-axis and this is y-axis. Now solving this inequation as a line, taking as a line, we are getting the point 5, 0 on x-axis. So this is 1, 2, 3, 4, 5 and the point is 5, 0 here. This is 5 and here we can take 1, 2, 3, 4, 5. The point is 0, 3. So here it will be 5, 0 and here it will be 0, 3. So now let us connect this line. Now this line is 3x1 plus 5x2 less or equal to 15. So we have taken 15. Less or equal to 15 means the shaded region will be below this line. Now we have 5x1, 2x2 less or equal to 10. So let us take 5x1 plus 2x2 is equal to 10. So z is equal to this much and we have 3x1, 5x2 less or equal to 15, 5x1, 2x2 less or equal to 10. For x2 is equal to 0, we get x1 is equal to 2. So x1 is equal to 2. The point will be on x-axis and it will be 2, 0. Now for x1 is equal to 0, x2 will be 5. x2 will be 5. The point will be on y-axis and it is 0, 5. So let us draw the graph. The first point is 0, 5. So here it will be 0, 5. This is the point. And a 2, 0. Here is the point. 2, 0. So let us connect these 2 points. And this line is a 5x1 plus 2x2 is equal to 10. So the shaded region is obviously will be here. As x1, x2 greater than or equal to 0, we have to consider the first quadrant only. So we have to consider the first quadrant only. Then the feasible region is, then the feasible region is O, A, B, this is C, O, B, C, O. The feasible region is O, A, B, C, O. So we are getting the feasible region, and this is shaded region is the feasible region now. Now we have to find the point B. To find the point B. So in order to find the point B, we have to solve the equation. We have to solve the equation 3x1 5x2 is equal to 15. 5x1 2x2 is equal to 10. So let us solve these equations. So multiplying 2 to the first equation, it becomes 6x1 plus 10x2 is equal to 30. Now let us multiply 5 to second equation. So 25x1 plus 10x2 is equal to 50. Now subtracting, we get, on subtraction we'll get 19x1 minus 19x1 is equal to minus 20. So x1 is equal to 20 by 19. So we get x1 is equal to 20 by 19. Then x2 is equal to 2x2 is equal to 10 minus 5x1 is equal to 10 minus 5 into 20 by 19. So this is equals to 120 minus 100 by 19. 190 minus 100 by 19 is equal to, this is 90 by 19. So we get x2 is equal to 45 by 19. So the point B is now 20 by 19. This is 45 by 19. Then we have Z is equal to 5x1 plus 3x2. At O of 0, 0, Z is equal to 0. At A of 2, 0, it gives us Z is equal to 5 into 2 plus 0 is equal to 10. At a 20 by 19, 45 by 19. So it gives us 5 into 20 by 19, 3 into 45 by 19. So this is 100 by 19. This is 135 by 19. So this is 235 by 19. At the point B, it is at B. At a C of 0, 3. Z is equal to 0 plus 3 into 3 is equal to 9. Hence, the maximum of Z is equal to 235 by 19 at a B of 20 by 19, 45 by 19. Answer. Okay, the problem is now solved. We are getting the answer for this question is maximum value of Z is equal to 230 by 19 at the point 20 by 19, 45 by 19. Now let us proceed to solve the next problem. Maximize Z is equal to 5x1 plus 6x2 subject to 2x1 plus 3x2 lesser equal to 6x1 x2 greater than equal to 0. Now solution. Given 2x1, 3x2 less or equal to 6. So let 2x1 plus 3x2 is equal to 6. For x2 is equal to 0, we get x1 is equal to 3. So the point is on x-axis and the point will be 3, 0. Now for x1 is equal to 0, we get x1 is equal to 0, we get x2 is equal to 2. So the point will be 0, 2. So let us draw the graph. This is our x-axis, this is y-axis. 1, 2, 3, 4. This is 1, 2, 3, 4. 1, 2, 3, 4. Now the first point 3, 0 is here. This point is 3, 0. The next point is 0, 2 on y-axis. So this is 0, 2. This is 0, 2. So now let us join these 2 points. So here it is given 2x1, 3x2 less or equal to 6. So we have to consider this side. Now x1, x2 greater than equal to 0. This implies we have to consider the first quadrant only. Then our shaded region is the feasible region. So this shaded region is the feasible region, having 3 points: 0, this point let us take A, and this point as a B. So okay, we are getting the shaded region with points 0, A and a B. So given Z is equal to 5x1 plus x2. Now Z is equal to 5x1 plus 6x2 at origin 0, 0. This is origin 0, 0. Z will be 0 at A of 3, 0. At A of 3, 0. This is the point. So the value will be Z will be 5 into 3 plus 0 is equal to 15. At B of 0, 2 implies Z will be 0, 6 into 2 is equal to 12. Hence, maximum of Z is equal to 15 at x1 is equal to 3, x2 is equal to 0. So we get the maximum value of Z is equal to 15 at x1 is equal to 3, x2 is equal to 0. Answer. So our second problem is solved. The topic for today class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.